All right, so quadratics here test, some good problems. This is not all of it, but still gives you a pretty good idea of what we have. So you're going to graph, and you need to include a table, and we just need the 3 points on it that I'm asking you. So each one, you've got to find the vertex. So the first one here, it's in vertex form. It's at -2, 5, because remember, it's what makes the inside 0. So -2 and 5, so 1, 2, 3, 4, 5. My vertex, I know that it's opening down because it's a -3. Make my table, so -2, 5. Plug in a value each side of this. And if you do that, if you plug in these numbers in for x, they'll be the same answer because of symmetry. And so -1, 2, 3, 2. And boom. Easy peasy. All right, next one, vertex. Let's clear ink here. And vertex is -b over 2a. Must know it. It's not going to be on the board or anything. So, yes, memorize. So it's 8 over, because it's the opposite of -8, over twice a. So that's 2. So the middle of my table is going to be 2. I go evaluate each side of it. It doesn't have to be 1 away. It could be more than that, but 1 away is sufficient. And so if I plug in these numbers in for x, so if I plug in 1 in for x, I'm going to get -3, I believe. And then 3 gives you -3. And if I plug in 2, I'm going to get -5. So 2, -5. So 1, 2, 3. And 1, -3. And we should mental check here, but it should be opening up because the a is positive. Now, if I plotted this all the way to the y-intercept, it would cross at 3. It's something we do know about quadratics. That standard form that y-intercept is at. Now, number 3, you're going to have large numbers for your vertex here. Not for your x value of the vertex, but for the y value. And we get to choose what our table is here. So we don't have to choose our increments on our graph. So we don't have to go by ones. All right. So if I plot 3 and -7, 2, 3, 4. I think that's -7. Not quite certain, honestly. And if you take the average of 3 and -7, so 3 plus -7, 1 or 2, so the average, so that's going to give you -2. So now if I'm going to plug in -2 in for x, okay, so I've got -5, I've got a 4, and I've got 5. And so if I multiply that out, -100. Okay, so I'm going to be at -2. So if I do this, I've got my two values that it's 3, 0 and -7, 0. And I have the value of -2, 1, -100. All right, so if I went by 10s here, I won't get there. If I go by 20s, though, that's -20, then that means that I can get down there really quick, 40, 60, 80, 100. So -2, -100. Just make sure you've labeled that, your graph there. And whoosh, there you go. Okay, factoring, you get all sorts of types here. Difference of squares. This is the a squared minus b squared one. So it's perfect squared, and it's a difference, meaning subtraction. So it's 2x minus 5, 2x plus 5. Again, it's because they're conjugates. The middle term will cancel out. Number 5 is a trinomial. It means there's 3 terms, but it's a simple one because the number in front of x squared is a 1. So we can just do 2 numbers multiplied to be 12 and add to be -8. So it's x minus 2 and x minus 6, because -2 times -6 is positive 12. -2 plus -6 is -8. Number 6, I changed that to 3x squared because this was not factorable if you try number 6. So it does not factor. I didn't want that for my test review. So this is the problem that I gave you guys. No greatest common factor. Leading coefficient is 3, though, so -18. So I need 2 numbers multiplied to be -18, but combined to be -7, so -9 and 2. We got 3x squared minus x plus 2x minus 6. So we're breaking that up. and you pull out the greatest common factor, so 3x, x minus 3. I can pull out a 2 out of these two. And so this is x minus 3 here and x minus 3 here. That's good. So you pull that out. So you're pulling that out of there. And the things that are left is the 3x and the plus 2. So that's the other parenthesis, 3x plus 2. So that's factor. Clear the ink here. And then this last one here is greatest common factor. There's something in common for each one of these here. So we've got in the 4x squared and negative 8x, we can pull out a 2. We can actually pull out a 4x. And so when you pull out that 4x, you're left with x minus 2. And that's it. That's all it is. It's the greatest common factor on that. All right. Solving. Set equal to 0. Anytime you have a trinomial, you could do the quadratic formula, which is negative b plus or minus b squared minus 4ac all over 2a. Is worthy of committing to memory. Or you could factor this one. This is a factorable one, so two numbers multiply to be 12. And this is the same as the one before, x minus 6, x minus 2. So make sure you pay attention whether it says just factor or solve. Notice that this one says equals 0, so that's why it's a solve one. And so you get x equals 6, x equals 2. Next one's a simple quadratic because it's in the vertex form here. So I'm going to go ahead and solve for the x plus 2 squared. Isolate that, so I'm going to subtract the 11 across. Remember, this is a Algebra 2 class, hence we will be allowed to have imaginary numbers. If you graph this left-hand side, they never cross each other because it's going to be imaginary, so it's negative 9. Divide by the 3, so you have x plus 2 squared, that was negative 3. So when we square root here, there's a square there. When I square root, this negative is just going to turn into the I, right? Square root of negative 1 is I. So now I'm left with x plus 2 I root 3. There's a plus or minus, of course, there. So my answer then is x equals negative 2 plus or minus I root 3. And you can put the I behind the radical too. That doesn't matter if it's here or if it goes here. Just make sure it's not underneath the square root. Solving this one here, got it equal to, we got to get it equal to 0. So we're going to bring everything across. We're going to bring the 2x and the 5 across, so negative 2x minus 5. So that way the right-hand side is now equal to 0. So 4x squared minus 10x plus 7. Quadratic formula. So negative b, the whole quadratic formula. So it's going to be 10 plus or minus. Negative 10 squared is a positive 100. Make sure you put parentheses when you put that in your calculator. So negative 10 squared is 100 because it's a negative times a negative is a positive. Better change colors. It's hard to see. And then minus 4ac, so 4 times a times c. So you get minus 112 when you do that. So another imaginary number here over twice a, so that's 8. All right, so I'm going to erase this over here so I can write over here. So now if I simplify this up, you're going to get an imaginary number. You've got 10 plus or minus, and this is going to be square root of negative 12, square root of negative 12, which is 12i, square root of 12i over 8. This does reduce. 12, remember, we do the breakdown, so 2 goes in there 6, 2 goes in there 3, or you recognize 4 times 3, so that becomes 10 plus or minus 2 root 3 I put it behind there because I forgot to write it. And now that there's a 2 in each one of these terms, I can cancel out. You cannot just cancel out here. That is not good. You've got to have it in all 3 spots to be able to cancel out. And so we do here. So it's 5 plus or minus 2i square root of 3. And again, the I could be in front or back. And that's your answer. All right, next problem. Given the vertex, write the equation. So write the equation, so it's vertex form. So it's going to be y equals a x minus 3 squared plus 8. The question is, what is a? So we're going to plug in the secondary point. So 10, 13. So 13 goes in for y. 10 goes in for x. And so if you solve this, you get the 8 coming across. And so this is 5 equals 7 squared, so 49. So 49a. That's really hard to see on there. The best color is here. All right. I guess red. All right. So a is 5/49, positive 5/49. So then my equation then is 5/49 x minus 3 squared plus 8. There's your answer. So vertex, use vertex form. Check. X-intercepts. If you have the x-intercepts, use the factored form. So I have y equals a, which we don't know yet, but I know that it's x minus 5, x plus 2, because remember these things are the negative 2 is what makes that 0. And so now I just plug in the secondary point of 3, 4. And plug in 4 for y, 3 for x, both spots. I'm going to solve this equation. So over here, this is negative 2 times 5, which is negative 10, so it's negative 10a. So 4. So if I do that, divide by negative 10, so that's negative 2/5 is reduced. Leave that as a fraction, that'd be good. So negative 2/5 goes for a. You got x minus 5, x plus 2. That's all it is. 13 is not as easy. This one here, you're going to use Gaussian elimination or RREF on your calculator. So this one here, 3 unique points. If I had more than 3, I need to use a regression, but I don't have more than 3. So there's another video on the regressions. And so I'm going to use standard form, ax squared plus bx plus c. This one's what I'm going to use. It's not the most desirable one, as you see, of course. Now I've got y equals, but I don't want y equals. Instead, I want equals y. And I'm going to plug in these points. So if I plug in 2 and 7, 2 for x, 7 for y, I get 4a, because 2 squared is 4. Oops. 2b plus c equals 7. That's the y value. And then I go to the next point. So if I go to the next point, I'm going to use 8, 9. So if I do 8, 9, 8 squared is 64. 8b is just x. C is always there, just 1. And it equals 9. If I plug in 11, 10, if I plug in 11 for x, I get 121a, 11b plus c equals 10. So go to your calculator, Gaussian elimination, or RREF. I love doing a problem on the spot like this. So when I just did this, it goes 1, 0, 0, 0, 0, 1, 0. I hit math fraction, 1/3, 0, 0, 1, 19/3. This does not make it quadratic, which is unfortunate. Oh well. What this is saying is that a is equal to 0, b is equal to 1/3, etc. So this means that it's 0x squared plus 1/3 x plus 19/3 equals y. So this, in fact, is just a line. I did not see that coming. So anyhow, oops, oh well. You did do this. It had a quadratic, which I know the test one is a quadratic because I've done that. You will get a number there, and that would go in front of x squared. All right, simplify, FOIL this out. So you get 15 minus 9i plus 10i, FOILing it out. And remember 6i squared, that I squared is actually equal to -1, so this turns into plus 6. And so if you combine like terms, that's 21 minus or plus 1i. Okay? All right. Next one is 1764 or 17,640. Reducing that radical, something your calculator wouldn't do. That's a big number, so we're going to break this down and do the big long tree. So this is just a good test for me to make sure you can actually do it. I'm going to break this down, divide by 2 until it's no longer even. Okay, so 17,640 divided by 2 is 882, well, 20, and then divide by 2. That's a horrible 8. And then, so if I divide that by 2, it's 4410. Still divisible by 2, 2205. No longer divisible by 2. So we go off to 3s or 5s here. It is divisible by 3, so I'm going to use a calculator here. You can do long division if you need to. 735. I check to see if that is divisible by 3. It is. 3 goes in there 245 times. Check it again for 3. And it is not. It gets a decimal, so I'm not going to do 3 anymore. But it is divisible by 5, so 245 divided by 5 is 49. 49 is a nice one. It is divisible by 7. Getting a little dark down here. So now this whole thing is root 2, root 2, root 2. There's 3 of them. Root 3, root 3, root 5, root 7, and root 7. So if there's a pair, then they turn into a singular to the whole number. And so we have 3 pairs. So 2 times 3 times 7. All right, so 42. So 2 times 3 times 7. And the things that do not have pairs, which is the 2 and the 5, multiply also. And there's your simplification. You could actually check this to make sure, verify that you have the exact same decimal. And so if you'd get 132.815, etc. Either if you do this one or this one, so you can check via decimal. All right, flight of a ball. So this one's the flight where it's in feet per second. Seconds is the time, feet is the height. So maximum height, that means vertex. So negative b over 2a. How long is it in the air? So that means that, if you've got this graph, it looks like this. Remember, story problems we can use the calculator on, so I got to find out when it's equal to 0. I can do the vertex by doing the maximum, so second calculate maximum. So how long is it in the air, though? You're trying to find out when it hits the ground. So you're going to have 2 equations. You're going to have this equation, and then you're going to have the secondary equation, y equals 0, and do second calculate intersect. Now, h of 3, this is an easier one. You just plug in 3 into this, okay? I'm going to give you the answers here in a second, but you're just plugging in 3 for time. H of 3 just stands for at 3 seconds, how high is it? But you have to understand that function notation is just a y, but this is telling us what to plug in. So 3 seconds, how high is it? And we'll plug it in here in a second. And then the last one is, when is it 100 feet in the air? So instead of being y equals 0, we're going to make that second equation y equals 100, and we're going to see when they cross. There's going to be 2 answers here, so you do second calculate intersect. I'm doing that on my calculator to get the answers here real quick. The maximum height, if I do the maximum part, is 3.75 seconds, but the maximum height is what I want, so it's the y value, so it's 228 feet. And make sure there's no naked numbers with story problems. And how long is this in the air? Remember, we want to know when it's y equals 0, so we're going to find out the second calculate intersect, and that's 7.52 seconds. We just want to know how long. That's just the time, so that's the x value. If I plug in 3 into this equation for the part C, so 3 squared plus 120 times 3 plus 3, it's 219. 219, there's supposed to be a 1 in the middle there. 219 feet. So at 3 seconds, it's 219 feet high. And then finally, when does it equal 100 feet? So you got the secondary equation with y equals 100. Remember, there's going to be 2 answers here. One is 0.92 seconds. That's the first one. All right, and then you go and do the second one. So second calculate intersect again. So now remember, you got to get closer to, you got to move your cursor to the closer to the second point if you're using a TI. And the second one is 6.58 seconds. We rounded 2 decimal places. And that's the ball flight one. All right, complete the square. Group, pull out a common denominator, or common term, so it's 4. So it's x squared minus 10x. And remember, it's always half that middle term. So it's negative 10, so that squared is going to be plus 25 and minus 25 because I'm actually effectively adding 0. Bring out the negative 25, but remember there's 4 of them. So we've got 4x squared minus 10x minus 25, oops, plus 25. And so this is negative 100 that comes out, plus 12 equals 0. And now this factors here to be x minus 5 squared. And we got a 4 there. It's always half this middle term, always. And I'm going to move the other stuff across the other side, which is going to be 88. If you don't know that, negative 100 plus 12 is 88. And divide by 4. So divide by the 4. So that's 22. Oops, no, 44, 4. So x minus 5 squared. I've effectively added, made it a simple one. Square root both sides. And so you get x minus 5 equals plus or minus root 22. This does not break down if you try it. So 5 plus or minus root 22. If you do 22 to try to break down, it just gets you 2 and 11, and there's no pairs. Okay, last problem. I should say problem types. So we do have some linear systems on here to solve it. So just a refresher, this is going to be a substitution. So 3x plus 6, and instead of y, we're going to replace it with 2x minus 5. Okay, and you're going to distribute and solve. So it's 12x. It's lent itself to being done by substitution. And so you get 15x, equals 60. So x is 4. Go back, plug it back in for x. So you get y, because remember we wanted the ordered pair, is 3. One is a good problem for elimination because it's stacked up already. So I'm going to multiply by negative 3 and 2 on the bottom one because it's 2 and 3. And if I distribute this, I'm going to get negative 6x plus 15y equals negative 36. 6x, the whole idea is to make those opposite like that, so that's good. 12y equals 60. Add them together, the x's cancel out, so you get 27y equals 24. So y is 24 27ths. And then you do it again. This time you're going to get rid of the y's. So I'm going to use a 6 and the 5. Now I don't include a negative because I already have the negative in that top equation. Okay, so if I multiply by 6, I get 12x minus 30y equals 72. And then on the bottom, I've got 15x, 30y equals 150. And so if I combine them, the y's cancel out, which is wonderful. So 27x equals 222, I think that's right. So 27, divide that across. I think I did that right. But that's the idea. If I didn't, my apologies. Just such a wicked number, but I believe it is right. It is correct, but it does reduce. I just checked it here to make sure it's 74/9. And so did the other one too. I didn't pay attention that both divisible by 3 to 8/9. So they do reduce. All right. These here, so y is less than 2x minus 5, so it's a linear one, so negative 5. So I think this is negative 5. It's hard to tell here. 1, 2, 3, negative 5, and it isn't dotted line. I'm going to go up 2 and over 1, and dot, 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 dot. It's greater than, so it's going to be this side. The other one we can't trust, so we're going to solve for y. When I solve for y, I'm going to get negative 1/2 x plus 5 because I subtract 3x across and divide by 6. And so that one starts at 5. Put a different color. 1, 2, 3, 4. 1, 2, 3, 4, 5. About yay. Down 1 and over 2. This time it's a full line. My inequality did not flip because I didn't divide by a negative. Even though this is a negative slope, it did not flip. So greater, so above it. So let's make that purple. So above it. So it's where the blue and the purple intersect. So this orange is the solution area. There you go.